Yeah, start. Yeah. Hey everyone, this is Pani here. I will be going through the function operators today, the chapter 11 from the book, advanced book. And that the objectives for this chapter today are uh, learning objectives of what's a functional operator and explore some of the existing operators and make your own function operators. Uh, this is relatively a short chapter, but for me to understand, I was exploring a little bit more than the other functions that are already available. So uh, just for the reference, so what's a functional operator? A functional operator is a function that takes one or more functions as an input and returns a function as an output. So it takes in a function, and returns a function. So it is kind of a function factories since they return their function. So function operators are a special case of function factories, like that what we discussed in the last chapter. um, it is compared to the Python's descriptors, which I'm not aware of it, but the book indicates that they are often used to wrap an existing function. We'll see how it is done to adopt the behavior of existing functions. So examples of some of the functions that it's already built in, or some of them are like, say for example, the function operators for modifying an input and output. These functions, like say I found some of the examples, like vectorize function is a function operator that which is a convenience function that turns a scalar function into a vectorized function. So it takes a simple function here, this vectorized function, which is already available to us. So if we this takes a simple function, the simple one, and arguments and all that function, and gives a random. Say when you run this one, it randomly assigns a, a number, a vector, or a vector from 1 to 5, 6 to 10, and 11 to 15 list, like list from. So what vectorize does is simply this repeatedly calling the original functions inside the m apply loop, and it does not magically improve the performance. That's what I was just playing around with it, and I saw this one, the vectorized. It just gives returns a vector, simple vector. Does not do anything. I never used it before, but I was trying to see an example of a functional operator, and it came out that one of them is vectorized function. So that's the one, and there are some other functions that are already there. Because this chapter was so dry, I couldn't understand a lot, so I had to go out, find out an examples, because all the previous cohorts are already like repeating the same thing what's in the book, which I could not really understand, so I have to go out. There is the some of the examples that I found is like there's other splat function converts a function that expects a multiple named arguments into a function that expects a single list of arguments. So the example uh, that I came up with is, see, this is a flat function it uses a force function. Okay, the force is there was a lot of argument between why we need to use the force right away. Is it force, if I understand it right from the previous chapters, is that it takes the argument right then and there. Like the first value that it gets in, it takes that and uses for the next function call. So, John, please correct me, or anybody correct me if I'm wrong. So that's what the force does here, right? Within the
It
flat
just
splat.
it just makes sure that f remains f if you change the value outside. Here it's not doing anything the way you're using it.
Mm-hmm.
But yeah, the purpose, of course, it doesn't really it just makes sure that f is not going to get evaluated lazily. It sets f to be what you passed in at that moment.
Okay, so but I thought of I don't know, like I thought of using it for the showing it, but maybe yeah, I'll just correct it. But this is what I was trying to do, and
Yeah,
what it does is simply takes the first argument, first list, the mean of the splat mean of this list, and if at all I would have done it differently, without I would have got a different, the
I
NAs,
see.
right? So NA and the second list. So something that's what I was planning. I was playing with is two of them. So the L apply the list of arguments applying the splattered mean. So this uh, the way of doing taking a function and reading it and returning it, using it within a function, then getting the results out. So it's already one of the functional operators that we can say it's already built in. And some of the other things that I found, or like where I thought of it, is time underscore it or capture underscore it. This is something that returns a function that executes the original function, which is system.time, that we use a lot uh, to capture the system time. And something the capture underscore it return the function that executes the original function. So I haven't used this capture underscore it, but it says that it prints output as a character vector. So this is already a function which is written on the top of the output, okay, or the function. So there are some internally built functions that are handling the errors, especially with the per package. So these functional operators typically from the per package modify the functions to handle the errors gracefully. This is useful, like in the previous chapters, we found out that it will be really useful to handle the errors, to let the user understand in a graceful way. Okay, so that's what the way it is there are the way some of them are per safely. The capturing errors turns errors into a data. Safely, f returns a new function that will never throw an error. Instead of it always returns a list in two components, results and error. So this the way it is, like the log, safely log, nothing but it calculates a log of the value that is used. So if we see this one, the first one, the log 10, is safe, the safe log, which is because it is used under the safely, returns a value, rather than the negative one, which does not, the log of negative one is no. So it actually results null value, which is an error value. And we can use this safely uh, function operator, which is already there within the per, and to improve the functional programming. That's what it says. There are some others, some of them others are per possibly. Possibly is it has two functions. It's basically has per the function operator, and otherwise returns a new function that returns a specified default value, and otherwise the original value fails. So basically we can customize the way it does, customize. So say for example, if says log of 10 the result, if otherwise, if I could say anything, like any real, I just said any real, and it would say warning if NAs are produced. So NA, I can customize the way it is going to throw out an error, or make sure that the user understands it right, or like makes it easier for the user, right? Instead of guessing or making a guess. So there are some kind of this is what I found very interesting, which I could not, I mean, like it's not in the book and all that. So functional operators for combining functions, maybe it's mostly used. I'm still learning this one. The function, like we can, there's one function, add one square, is the square of the function, and I can combine these two functions
Mm.
together and use it with this operator. I haven't seen this one before. Maybe like somebody else have used it, but when I was reading this book, I found out this operator, like something, so creates a new function and does that. So if I run this code, what it does is function of x add 1. So first I said square, right? So square, it takes a 5, 5 plus 1. First, it takes the value of 5 and then adds it to 1 to it and then squares it. So even though square after the add, these are two different functions, and I'm trying to call within one function here. So with this operator, so what happens is that it combines those two functions and does the calculation.
Can I ask a question? So the dot 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 in the inner function, is that capturing oh, okay, I understand. Okay, so 5, it could be anything.
Yes.
And 2, all right.
Yeah, it was something very neat technique. I mean, I never seen this before myself, so I'm still learning a lot. But I found this technique and this function this to be very interesting. So I thought of adding it to the book club thing. So this is what it does, and there is the one something is functional algebra thing. That's another example that I found. The function can be combined the functions that return a logical value into a single function. Even this one, I mean, like it's like kind of if-else statements, but it can be applied in a wider range of things. And found very useful. I mean, for me to understand all this stuff is like, say, if I run this one, the first one, the first function checks is if it is a positive number, and the second function checks if it is less than 10. That's the two functions, two different functions. So what he said was, is positive, then I have another function call which takes the and ampersand ensures a lazy evaluation, and also make sure that f dot 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 is always stops if f is false. So this function would fall. I mean, like fail stop if this is false. So that's the one function, and this is the two functions. So when I combine everything in the third one using the way this call and try to evaluate my values here. Now, is small and positive 5? Yes, 5 is greater than, is a positive number and less than 10. So it will always result, I mean, it will give me a result true. But is small and positive 15? It is greater than 0. Yes, it is positive number, but greater than 10, right? So it would result in false.
Why would it stop if f dot 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 is false?
Because
And
and will stop if the first one is already false. It doesn't care what the second one is in that case.
Yeah, but stop just mean it returns the first one.
Yeah. It stops trying and stops evaluating.
I was like, I thought stop. It's gonna error.
Yeah, not error, stop, sorry.
No, this is really interesting.
Yeah. There's also well, go ahead.
Sorry.
I want to wait.
Oh,
okay. See where
oh, sorry. Yeah, this is what I thought. So the way of writing this one for me would be is okay. Cluster it takes a cluster array of reading the big functions, and I can break my functions into smaller ones and use it as possible. That's what my process of understanding why and where I can use this one. So this avoids the scattering of logical conditions throughout your code and centralized filter. So that's what my way on my application of want to use this one. So there are others which will be really helpful for people who can understand or when writing the functions is possibly quietly and auto browse. I could not use the auto browse because I don't know, like I was trying to do it, never like, so there was something which is nearer to it. So I'll show, we'll talk about it, but possibly and quietly, or the per functions and possibly returns a default value when there is an error. It provides no way to tell if an error occurred or not. So it's best reserved for cases where there's some obvious sentinel value. Like say, it does not stop you, but it does make sure that, like it does not return the error right away. And output and quietly it gives you an output message and warning of side effects. So it says, sorry, I was looking at the chat window, but I'm a little bit moving little forward, but I will talk about the chat window in a while. So in possibly function operators from the per package, say for example, the possibly function takes two arguments. The argument, the function that you want to use, and otherwise. So if this is failing, what should be done? So that's kind of an argument it can take. So if we see this one here, right? I just want to have a log value of 10, 100, -5, and so this is the list that is going to go. So what happens is that the possible will go with each iteration, with each list value, and if at all it can find the logarithmic value of this one, it will give the result out. But if it is not able to find it, then it will produce a warning. So something like this one, say result would be printed out, but when there is an error, it would print out the otherwise value, the other thing, and then continue with that. So that will be really helpful when to see where the possible values and producing it out. So the way it is done is this way. And the main use of possible is within the functional programming tools is like lapply or map when it is processing a list of vectors that may contain the element. I mean, when the data is that you make sure that the data is not always the way you need it to, then the I would do is use the possibly option so that I can know where the data is different or where data is not falling into the lines, and then I can either build around my function around it or make sure my data is. I mean, most of the times that will happen in the medical world is the data is not always clean. So we always make sure that we write a macro or a function, make sure that it whatever it is clean, and then clean the remaining data or write a function around it. So this ensures the iteration completes, and you can review the results, review the failures later. So I can review it later instead of making sure that everything fails and think through it why and where it happened. So I thought that would be useful for it. And quietly is a function operator for package, modified function that captures and silences all the messages, warnings, and printed output. And I believe, John, I'm not sure, is this might be one of the things that they might be using when uh, the two or three different packages have similar names or something like that. I mean, like when they have conflicting names, is this something that they are going to use that, or is different?
It's different.
Oh.
This is best, or I have definitely used this when like you're going to make a call to an API and you want to keep going even if there's an error, and then you'll just log that there was an error for that entry, things like that, where you don't want an error to stop the entire thread of whatever you're doing. So
Okay.
instead you just capture that there was an error and deal with it later, but you run it for everything. I do want to pause for a second because your possibly example, the reason that you're getting those NANs introduced errors is log in R doesn't actually error. It just throws a warning. And so possibly is never actually getting called by this.
Oh, which one? The one
This
before?
whole screen. So the reason that you're seeing NaN instead of Na
Okay.
is log of -5 doesn't throw an error. It throws a warning and then returns NaN. And so this example doesn't actually work.
Okay, I have to cross check that. Sorry.
Yeah.
I'll cross check and do that again. Maybe something has to be done. But I understand what you're saying. So I'll play with it and I'll let you know, like, and update this one, whatever it is supposed to be done. Okay. And yeah, and safely, as you said, that like it gives you. It can like, say, for example, that's what I was thinking is a message is chatty function that it's in as per the book. Is that a start calculation? It would do that input if the input is less than 0. I would like to have a warning. I mean, like saying that input is negative and results is unexpected, but I do not want it until I wanted to see. I mean, I just want to, as John was saying, that I wanted to continue the function and then see the results if it is actually doing whatever it is done. So for that kind of sake, safely can be customized as per the requirement. I mean, like, you can always have a lot of the warnings and even the messages, everything can be customized, and that would be really helpful to me for the people who are writing the function. So for example, if I run this one, I see this one does not. I mean, like, the silent, like, you can see what's been produced from this one, if at all, like in the messages, right, in the present, the result of whatever it is being from this function. There's a result function, there's an output and a messages, and it would give us out in detail, like what's been printed out, or what is being generated out of this function, and then the what is the messages. So if there is if this function fails, so for example, if you are using a -1, it stops. Basically, the warnings is always. So if we see that if everything goes fine, the warnings is always null. So the warnings of the characters just prints out. It doesn't do anything here. So, but if at all there is warnings, it would say the input is negative, which is what we said here. If it is negative value, it would print out what we wanted. So safely is when we use in that way. So that's what I wanted to discuss today. But we have auto browse, which could not work. I mean, for me, but sorry guys, I have a very very hard stop that I need to go for a day job.
No
John,
problem.
you might want to continue, or just it's just these things, but remaining all of stuff is memorized function, which I could not use it.
Yeah.
Not.
Yeah. Okay. Yeah, we can keep talking. But thank you. That you got through the meat of it. So
Sorry. Yeah, I have updated that, and I will talk little bit.
yeah, no problem. And yeah, I've got the slides up that we can pull up, or we can just kind of talk about it, because there's basically one more slide, or the one that
Yes.
he's got up. So
Yes, sir.
Thank
you.
Yeah.
Thank you. Bye.
Thank you very much.
Thank you, sir.
Good luck.
Yeah, enjoy your meeting.
Yeah.
So yeah. So, Stas says in chat how, I have also dealt with like just noisy functions that you're calling them with a vector and it's returning a warning, or it's throwing a warning for each member of that vector or lots of the members of the vector. And so I have definitely done that where I just use quietly to capture them. Now the difference is like if you just don't care, you can just suppress warnings on the call. But if you want to check the warning, usually is what I'll do here is you capture the warning and then make sure it's the warning you're expecting and turn it in. Generally, I'll turn it into an error if it's not the warning I'm expecting. And otherwise, just let it go. Yeah, I've definitely had that case as well, where it's like, just, yeah, shut up. I know. Yeah, I guess I kind of, and yes. I kind of wrote an operator this weekend, I guess. That thing that I posted in the channel was technically an operator because it takes a function as an argument and it returns a different function. There's also in per, there's compose, which is basically the like what he was talking about. It wraps two functions or multiple functions, one or two or more, I guess technically one or more functions together, and then like concatenates their arguments. So it does pretty, like if you dig into the code of it, it's doing some complicated work to make sure that any arguments you pass in that are named are going to the right place. But yeah, it's a way to combine functions into one function. I've never, like with the pipe, I've never had.
Yeah, I don't see like.
I guess, I mean, I guess I've kind of done that. I've made a, I just make a function that does the two things or the three things or whatever. And I guess compose is a shortcut for that. But it is interesting if you look at the code for compose. Like, it's like, oh yeah, it tells you like, okay, the help for compose says that it's equivalent to this. I'll paste it in the chat. It's just like what he said, basically, of, oh yeah, it just wraps the two functions together. It's simple. And this is the actual code of compose. And so it's not quite what he says it is. It's like it's equivalent of that. Well, okay, but you can go backward or forward, and it deals with it's actually calling itself. Somewhere in there was like, yeah, if there are zero functions left, so that if not length fn's, it just does a compose on part of the input. It's doing, it's doing all kinds of crazy things. Yeah, formals of compose is formals of the first function because it's taking the arguments of the first function. And yeah, and then it returns at the end, it's returning a special type of function, which is always fun because then those types of functions can have special rules for like subsetting or whatever. And so you could theoretically, oh, I wonder if he has that set up, that you could theoretically subset the compose function to pull out the pieces. And so anyway, it just amused me when I looked at this. I was like, oh, is this basically what he just, well, no, I mean, it is basically what he just said, but it's doing a lot more work there to make sure that things are being called in the environment that you expect and all that.
Yeah. I feel like this is like very. I'm sure there's a very good niche for this, but like you said, like if you with the pipe operator,
Especially with the base pipe, where
yeah,
you're not even losing any speed or anything. And here, like this is so complex. Surely this compose is going to cause speed problems.
right.
I mean, the first time, as long as you actually use it, then it'll only have to actually do the composition once, probably, depending how you use it. I don't know. I haven't had a case where I've needed it, but I know it's in there.
I could see
Um,
like some complex mathematical like equation, like it might be helpful, like they compose a bunch of transformations, just so you can call one thing multiple times. Oh,
I suspect that I have code that I could replace with a call to compose, and technically it would be neater or whatever, but also much harder to understand. So
right, yeah. So there's a balance.
um but this one I am guessing, especially by how complex it is, I'll bet it is used inside of per, and he
Mhm.
just said, I guess I'll export it. It's useful enough. And I'm actually a little curious about that right now, so I want to try to find out. Um, let's see. Yeah, okay.
I
So
never
there's like
heard about
there's a negate function
it.
that just calls compose on the not operator, and then the function that you turn it or send into it. Um, looks like partial is using, where are you? Oh no, it's mentioning compose, but it's not. Yeah, partial is actually, forgot about that one. It's um another one that's in per that I don't think I've actually used. That takes a function and like will pre-fill some pieces. And actually, I just realized I think the thing I wrote this weekend would be much cleaner and easier with partials, so I might have to rewrite it. Oh wait, no, but I don't want to use per in that package. Anyway, um, it's yeah, there are definitely some very complex things in per that nobody uses. That one of these days we're gonna have to do like a per book club and go
Yeah,
through and find all the
yeah. I
secrets.
feel like a lot of our lib packages, like I was thinking the other day, there's so many packages where like I use like only 5% on what they
Yeah,
have, and it's like I'm sure
we
there's
did a book club once for um like the packages. We did rlang and we did test that, and we did CLI in there, and just reading the entire help documentation of those packages as a book.
oh
And
wow.
I learned a ton from that. Like advanced R is like the a lot of it is the rlang documentation.
Yeah.
Uh but getting into, there are some really complex things in there, a lot of which I've still never used, but at least now I know they're there and
Yeah,
have thought about them. Uh,
yeah, I'll have to do that too.
oh,
Yeah.
right. Okay. Um, cool. So next week, as we talked about at the beginning, we're not meeting because the daylight savings time insanity.
Mhm.
Um, and then the week after that, Ella said she will be able to be here to present the introduction to OOP and base types. Um, yes, so chapter 12. I think, yeah, in the book, there's technically like there's an introduction chapter that doesn't get a number, but it's worth reading. So got a couple weeks to start prepping for that.
Mhm.
Um, and yeah, then we have our whole uh object-oriented section. It's actually worked out pretty well. I didn't aim for this, but we finished a major section of the book, and then we have a couple weeks off before we go into the OOP section. So,
Nice.
um, I plan to keep chatting in the on Slack. So if anyone has any thoughts or questions, definitely we can talk there.
Cool.
Um, yeah, I don't know if anyone had anything else they wanted to talk about in here. There are some exercises, and we didn't go through the case studies. Um, but I feel like he kind of went through the case studies in that we looked at, like he built a bunch, so I think we're good.
Yeah.
Um, yes, cool. All right. Well, I will see you all on Slack, and then I will see you all here in 2 weeks.
Good to see everybody. See y'all.